TPCx-HS performance benchmark.
Hi everyone, my name is Karthik Kulkarni. I'm a Big Data Solutions Architect on the Cisco UCS team. Today we'll be talking about the TPC benchmark for big data systems, and we'll be talking about Cisco UCS integrated infrastructure for big data and some of the results we announced on the TPCx-HS benchmark for big data on the architecture itself, and we'll open the floor for Q&A. So as most of you are familiar with TPC, so just this last year we announced early last year we announced the TPCx-HS benchmark for big data. So this is the industry's first standard for benchmarking big data systems for verifiable performance, price per performance, and also verifiable metrics on both infrastructure and software systems. So this is actually based out of like it's a committee of pretty much who's who in the industry on the big data. So you have both the infrastructure and the software vendors for big data systems. And these are the associate members. But in a high level, the TPCx-HS benchmark itself is based out of it's on the lines of your TerraSort and TerraGen and the TerraValidate. You have something similar on this, which is called the HSGen, where you're actually creating a terabyte, or it depends on whether you're doing a terabyte kind of test, or even it goes all the way to a petabyte testing. So you're generating a three-way replicated data, which is synthetically generated and uniform distributed on a durable media. So it's not going to be in memory. It has to be written to the disk. Then this is three-way replicated, and then you run a validation, which is called the HS data check, which is going to check that it's all three-way replicated, the data is correct. Then you're running something called as a HS sort, which is in lines of your TerraSort again, but the difference is you're making sure that this is again three-way replicated as well, and it's returned to your durable media. Finally, you're doing the verification, which is in lines with your TerraValidate, where you're making sure the data is correct, it's three-way replicated, and it's stored in the storage. Before going into some of the results we announced a week before and 2 weeks before, these tests were done on Cisco UCS integrated infrastructure for big data. So let me introduce you to about our architecture, because the results are in the context of the architecture. And the Cisco UCS integrated infrastructure for big data is the third generation of our offerings of reference architecture for big data system. And Cisco, we just don't offer just the server. We offer an architecture, an integrated architecture, which includes your networking, server, storage, compute. And all of them are managed through what is called a UCS manager, which is running on the Fabric interconnect. Your networking is run on the Fabric interconnect, which is called the F5, which hosts a software module which does your complete provisioning of your infrastructure from your network, servers, the compute, the storage. Whether it's the RAID, we'll touch upon a little more of that. And these are connected. The UCS, while the UCS manager is the brain of your infrastructure, the core to that is of course the servers, which does your compute, storage, and of course it's connected through a dual 10 gig to your network. And this could be extended as well to either one rack, which is 16 servers and typical, or 160 servers. And this is a Fabric extender which allows for network over provisioning if you want to. A direct connectivity, a recommended architecture is 80 servers. And Hadoop by nature is your storage is local to your compute. So we do have different options for your servers, and the test itself was run on the first server, the C240. So for Hadoop kind of workload, the first two, which is the 2RU servers, the C240 servers, are very common deployment. The 1RU server, which is the C220, is ideal for your NoSQL or big data analytics kind of workload. And the C3160 is designed for archival kind of workload. And all these servers come with dual dual sockets, Intel Xeon E5 2600 series, especially the test which was run on C240 with 24 drives. The small form factor drives was 2680 V3, which is 48 cores with hyper-threading. And the memory on each of these servers is, the default is the 256 GB. You can scale all the way to 768. And the storage on these servers can go from, if you're looking at a small form factor servers, which is the 1.2 terabytes, you're, for a rack which is 16 servers, you're pretty much doing 460 terabytes, which is half a petabyte of storage. And the C240 with the large form factor is, you can go with 4 or 6 terabytes of storage. We are also coming up with 8 terabytes. So if you're looking at 4, it's 3/4 of a petabyte, and 6 is roughly a petabyte in just one rack. And as I mentioned, the core to the infrastructure is the servers, but the brain is the UCS manager, which is the software which is running on the Fabric Interconnect. What that does is pretty much every aspect of your infrastructure, from the network and from the servers, the network compute, storage, whether it's your BIOS policies, your network policies, the QoS policies, what is your WIC, how many WICs are you. So we have a concept of virtual NICs through a WIC, through our Cisco. What we have in a UCS is not standard NIC. We have a converged network adapter called the virtual interface card, where you can carve out 256 PCI compliant virtual NICs. This is all virtualized in hardware. So pretty much all of it is managed from the software through a concept called service profile. So you create a service profile template and say, hey, I need so many VNICs, and this is the QoS policy, this is the VLAN, this is the kind of UUIDs I need. Yeah, pretty much, or the BIOS policies, your RAID, your memory settings, the computer performance settings. All of this is managed from the software and blasted to the server, giving the server an identity. So how is this useful? Whether it's one server or a rack of servers, you're pretty much pressing the same number of keystrokes, all managed from the same pane of glass. Or you want to scale to 160 servers, you can pretty much configure or provision your complete infrastructure in a few minutes to an hour. So it's very common that customers tend to buy, like, start off for a Hadoop kind of workload with 1 or 2 racks, and within a year there are more than 100, 200 servers. So when you have to scale with your data, the UCS manager makes sure that it's as simple as setting it up and reducing your provisioning time by 90%. And of course, you can scale this to thousands of nodes with interconnecting multiple of such domains through UCS Central, which is like a manager of your manager. And this could be interconnected through Cisco ACI. We have a separate booth there. Now let's come to the benchmark itself. So we did announce our first, so we do have different bundles for your big data systems. So the starter bundle, then your high performance, which is ideal for your big data analytics or your NoSQL kind of workload. The test itself was run on performance optimized, which was 256 GB of memory on each of your servers, 24 drives in each server with 1.2 terabytes of storage. All are 10K RPM drives, and this was dual connected, 10 gig connectivity, dual 10 gig connectivity to the Fabric Interconnect. And the processor was 2680 V3, Intel Xeon dual socket, so you have 48 cores with your hyper-threading on. And the architecture itself is, we had 16 nodes. This is again the high performance configuration, 16 nodes which was hosting the data, and 1 node for your management. And we had it connected to Fabric Interconnect. We had Mode 6 bonding, and we had it connected to another switch, which was the 9K. We announced our first result, which was on a previous generation. So this is, we announced our first results in January first week on a previous generation, and we announced on the current generation of our infrastructure, which is the third version of the common platform architecture called the Cisco UCS Integrated Infrastructure for Big Data, just 2 weeks back. So this is all the results that we have announced. If you look, the top 3 are the first generation. We announced the test on 1 terabyte, 3 terabyte, 10 terabytes, and the new one was on the 3 and the 30. So just to talk about what is being displayed here, this shows the performance. The performance, which is called the HSPH, this is a normalized number. It says how much of HS sort are you able to do, the whole test. Are you able to do normalized to 1 hour, which is divided by 3600 in seconds, and normalized to 1 terabyte. So if you do a 10 terabyte job, you divide it by 10, and then whatever is the number, you again divide it by 3600. So that is like normalized. And if you have the same twice the size of the cluster, that means your number gets double. So higher the number is better. So twice the number is 2 times faster if it's on the similar cluster. Then we have a concept called price per performance. So the price per performance concept is, if you look at the results which is published on TPCx-HS, you have the complete price of your cluster with discount. So it has what is your cluster going to, if a customer is going to order something right after a week or a month, if it's published, it's pretty much in the ballpark of that, maybe a percent here or there. But it's going to be the official number with all the discounting from all the software and the hardware, what is going to be the end result to the customer. So the price per performance is your total cost of your infrastructure, including your software, and then you're dividing it by the performance. So better the performance for the same cost, you would have a lower price per performance. And the reason I'm spending time on explaining this is, if you notice, on the same or pretty much similar architecture we just had, we not just doubled our performance, because it's all normalized. These numbers are all normalized to a single terabyte kind of test. So whether you do a 30 terabytes or a 100 terabyte run, it's normalized to a 1 terabyte. So you can take this number as and compare it with any other terabyte test. So if you look at this number, we not just doubled our performance and even reduced our price per performance in the new generation. There's a lot of reason to that. If you look at it, for pretty much the same cost or the lower cost for our new generation servers, we've added 10% more drives. All the drives are 10K RPM compared to our earlier generation 7.2K. That gives you a 30% improvement in your IO bandwidth. And the compute itself is adding 50% more cores. We were doing an earlier version of Intel Xeon. And now we have the V3, which adds 50% more cores and faster cores. The memory itself is the new generation. So the new generation is not just over 2 times faster, but also cheaper. And this is some comparative results. So this, as I said, is an industry verifiable performance and the performance price per performance test. So we do have some test runs. These are all available, publicly available, including the complete configuration, how you went about configuring the system. So we did announce one where with 30 terabytes, we have a lesser price per performance, in the sense this price per performance, the lesser it is, it's better for the customer. And if you look at it from a point of performance alone, so the Cisco results were run on a 16 data nodes and 1 management. The Dell results were run on 31 data nodes. If you're looking at linear scaling, we are still 25% faster on our new generation and cheaper from price per performance. This is again on the 3 terabyte results. Here we are not just, we have some comparative results with Huawei. And we are faster and cheaper from price per performance. And the architecture was on the same lines. We had 16 data nodes plus 1 management node. They had the management was also shared by the data node. So this is, again, we're just talking performance. And as I mentioned, when Cisco entered the server market 6 years ago, we brought in a lot of innovations which kind of changed the market dynamics. So one was, as I mentioned, the service profile concept for provisioning. We have a detailed white paper on this, but we do more than 80% reduction on provisioning times, because it's all abstracted to the software and you blast the profile or context to the server and giving it an identity. And with our WIC technology and the fabric interconnect supporting both storage traffic and Ethernet traffic, you have reduction in cables. and we have 100 plus world records. And given this, and also from a big data point of view, we have the most extensive partnership, whether be it Hadoop or MPP or even your analytics. And no wonder we are like the fastest growing in the Blade. We introduced the Blade server 6 years ago, and we are number one in the Americas, beating most of the competition who've been in this business for over 2 decades. And we have over 46,000 unique customers and 100 plus world records, as I already mentioned, in 85% of Fortune 500. No, we configured as JBOD and we had XFS, yeah. No. So we ran RHEL 6.5 and each of these nodes, the drives were JBOD, and we configured XFS and we